We now demonstrate how to use Excel solver to obtain the sensitivity report. As we know, the sensitivity report can give us useful information about optimal solution, range of optimality, range of feasibility, settle price, reduce cost, and binding control information. Now let us use the Blue Ridge hot tub case to demonstrate how to obtain the sensitivity report. In this case, we have the marginal profit of two products, Aqua Spot and Hydro Luxis, as 350 and 300 respectively. We have three constraints of the pumps, labor, and tubings. We also have the right-hand side value of 200, 1,566, and 2,880. Now let's run the Excel solver to obtain the sensitivity report. We already input all the data in the solver and we solve. In these pop-up windows, on the right-hand side, among the three reports, answer, sensitivity, and limited, the most useful one is called sensitivity. So you just need to select the sensitivity and we say, okay. You can definitely also call the answer table or the limit tables, but basically we can get all those information from the sensitivity table. So we are going to focus on the sensitivity. We say, okay. In the Excel file, we can see that we have popped out called sensitivity report 1 on the left-hand side of the current LP model production report. So we clicked on there. We enlarge it a little bit. As you can see there, we have two tables right now. The top one is called variable cells, also those decision variables. So in this table, we have the first decision variables, the Aqua and the Hydro, the second one. Our current final value will be 122 for the Aqua and 78 for the Hydro. Those are the optimal solution for the two decision variables. If we look at the right end of this table, we have the allowable increase and allowable decrease for both decision variables. For X1, we have 100 for the allowable increase, 50 for the allowable decrease. For X2, we have 50 for the allowable increase and 60.67 for the allowable decrease. We also have the current objective coefficients information. That would be 350 for X1 and 300 for X2. We also have the reduced cost information. The reduced cost means how much we need to reduce the current cost in order to produce the product. For example, we have 0 for Aqua Spot. It means we do not have to reduce any cost in order to produce Aqua, because the current marginal profit for Aqua is sufficient, big enough. So we have the final value 122. Similarly, for Hydro Luxis, we have 78, the current value. It means we do not have to reduce any cost in order to produce Hydro. Coming to the second table of the constraints, we have information about those three constraints of the pumps, labor, and tubing. Look at the current right-hand side value of the constraint of the right-hand side. We have the 200, 1,566, and 2,880. We also have the left-hand side values. We call final value. And for example, for the pump, we have 200 as well. It tells us some information about the constraint. If your left-hand side value equal to the right-hand side value, it means the constraint is binding. Similarly, for the labor constraints, we have the final value of 1,566, which is equal to the right-hand side value. So the constraint of labor is binding as well. But for the tubing constraint, we have a left-hand side final value of 2,712, which is smaller than the current right-hand side value of 2,880. So the tubing constraint is not binding. At the same time, you can see that the settle price for the tubing constraint is equal to 0. For those first two constraints which are binding, we have non-zero settle price. For the pump, we have 200, and for the labor, we have 16.66. As we have discussed previously, 16.66 means at most we would like to pay for each individual hour of overtime. In this table, we also have the allowable increase and allowable decrease together. Combining these two, we are going to get the range of the feasibility. For the pump constraint, we have the allowable increase of 7, allowable decrease of 26, which means for the range of feasibility, the lower bound will be 200 minus 7, which is 193, and the upper bound is 200 plus 26, which is 226. And that's the range of feasibility for pumps. For the allowable increase for the labor, we have 234. Allowable decrease is 126. For the tubing, allowable increase is 1e to the order of 30. Actually, Excel cannot display the infinity sign over here. So Excel use 1e to the order of 30 by default to express is a huge number. So you can also consider as infinity.